Alright everybody, welcome back. In this video we're going to pick up where we left off with the last video. We're looking at implicit differentiation examples 3 and 4. So let's start with example 3. We're finding dr d theta if r squared is equal to 2r minus r cosine of theta. And so we'll go ahead and we'll take the derivative of r squared with respect to theta using the chain rule. Derivative of the outside, leaving the inside the same, times the derivative of the inside. The derivative of r is dr d theta. That's equal to the derivative of 2r, so that's 2 times the derivative of r, which is dr d theta. And then minus, we need to apply the product rule to r cosine of theta. So we've got r times the derivative of cosine of theta, which is negative sine of theta, times the derivative of theta, which is d theta, with us 1, plus cosine of theta times the derivative of r, which is dr d theta. And now I will distribute. 2r dr d theta equals 2 dr d theta minus r times the negative sine of theta, which is going to be plus r sine of theta, minus cosine of theta dr d theta. Now I bring all my dr d theta terms to one side and all my non-dr d theta terms to the other side. So I'm going to subtract 2 dr d theta, and I'm going to add cosine of theta dr d theta to both sides. Gives me r sine of theta. I'm going to factor out my dr d theta. And then I'm going to divide both sides by the remaining factor to get dr d theta. So dr d theta is equal to r sine of theta all over 2r minus 2 plus cosine of theta. And there's my derivative. Alright, example 4. We're supposed to find the lines that are tangent and normal to the curve. Oh boy, and I forgot the right hand side of the equation here. It should be x squared plus xy minus y squared equals 1. Sorry about that, typo on my part. X squared plus xy minus y squared equals 1. We're supposed to find the lines that are tangent and normal to this curve at the point 2, 3. Now if you think back to writing tangent and normal lines, we need two things to do that. We need a point and a slope. Well, we already have the point. So what we need now is we need the slope for these lines. And to find the slope for the tangent line, we need dy dx. So we're going to take the derivative of this original equation. We've got 2x plus, and then we need to apply the product rule to xy. That gives us x times the derivative of y plus y times the derivative of x minus the derivative of y squared, which applying the chain rule is 2y dy dx, and all of that is equal to the derivative of 1, which is 0. And now we're going to go ahead and solve this. I'll get all my dy dx terms on one side and factor the dy dx, and take everything to the other side by subtracting it away, and divide both sides by the remaining factor. And I get this as my equation for the derivative, dy dx. And now, for the tangent line, I'm just going to substitute the point 2, 3 in here to get the slope of the tangent. I'm going to evaluate this at 2, 3. Negative 2 times 2 minus 3, all over 2 minus 2 times 3. And that's negative 7 over negative 4. So the slope of the tangent line is equal to 7/4, which means that the slope of the normal line is equal to negative 4 over 7. And now I can write my two equations. My tangent line is going to be y minus 3 equals 7/4 times the quantity x minus 2. And my normal line is going to be y minus 3 equals negative 4/7 times the quantity x minus 2. And there are our equations for our tangent and normal lines using implicit differentiation in this context. Alright, that's the end of this video and the end of this lesson. See you guys next time. Hope you have a great rest of your day.